Okay, good afternoon, everyone. Today I'm going to talk about the CCI XG Testbed. The CCI stands for Commonwealth Cyber Initiative. Let me just give a brief introduction to what is CCI. The Commonwealth Cyber Initiative is an initiative that has been created by Virginia State local government, okay, in partnership with academia and industry. Is a set of 41 institutions in the state of Virginia, okay, where we have more than 300 research associates. And the Commonwealth Cyber Initiative is basically divided in 4 regions across the Virginia state. We have the Southwest Virginia node that is led by Virginia Tech. We have the North of Virginia that is led by George Mason University. We have Central Virginia that is led by DaSilva University, and you have the coast of Virginia that is led by Old Dominion University. And of course, we have a central node that orchestrates all these universities. That is called CCI, that is also located in north of Virginia, and the Virginia Tech Research Center building located in Arlington. The CCI Testbed is composed today of 2 sites, okay? We have the radio network, that is an indoor site. That's what I'm going to go to talk today. And we have as well, under construction, we have the CBRS private network that will be outdoor in Blacksburg, Virginia campus, University. Virginia Tech, we hold the TLA CBRS spectrum for experimentation. And then this spectrum covers part of the Virginia Tech campus and part of the Montgomery campus. As I said, I'm going to talk today about the radio network testbed, that is the indoor testbed that is being deployed, and the CCI in Arlington, Virginia Tech Research Center. The radio network that we are deploying is the main goal is to have as a radio network, as a platform, as a service, okay, where you can bring together industry, government, and academia to play together in a playground, to run experiments, to test, to validate. And also one of the main goals of the overall testbed that we are creating is to create workforce development. The overall end-to-end testbed is completely based in the open source platform, okay? It is ORAN based as well, and is completely aligned with the Commonwealth Cyber Initiative vision. What are the main 3 building blocks of this vision? Research and development, okay? Where we are focusing on advanced wireless communications autonomous systems. Virginia Tech is well known as being our strong research group in wireless communications in the world. Then we have the innovations where we look to working with cutting-edge technology, software and hardware. A good example of this is the open radio access network overall ecosystem. And also, that is the main focus is that use this testbed, this platform, to create a workforce development. As we are aware, as the cellular telecommunication network moving from 1st generation, 2nd, 3rd, and 4th generation, 5th generation, and beyond, the overall system network is getting more complex, okay? It's not easy to understand. And we don't have in the market and also in the academia, the workforce development, the research that can understand and have the hands-on experiment to really develop and understand all layers, from the application layer to the physical layer of the cellular telecommunication network, and how these layers can talk with each other and in this network softwareization work. Here you can see some pictures of the radio network that we have been already deployed in out of Virginia. I'm going to go to talk more about this in the next slide. Okay. A good example of the workforce development that we are doing at CCI. 2 weeks ago, we have what we call CCI Cyber Camp, okay, where we brought together some undergrad students from Virginia State selected to come to our testbed, to experiment. And in this picture, as you are seeing, these students are the undergrad students, and we coach them and we teach them how to deploy their own cellular telecommunication networks. In this setup, they use a D210 experiment, and as we are as well focused in cybersecurity, we emulate a cyber attack and this cellular communication that they create, where they need to dispose of this attack and shoot down the attacker. Well, the radio network from CCI Testbed is composed basically for key components, okay? And this is a mismatch of 72 radios deployed on the ceiling. These radios are a mismatch of X310, X410, and the N310. And the idea is that we have an end-to-end O-RAN platform, okay, where you have the AIML, that I'm going to talk later, the software. We have the non-real-time RIC, near real-time RIC, and the radio access network. And as well, we consider as well the 5G core network, the core network with what you have, all the socialization and macro servers. As I said before, the CCI Testbed is an end-to-end open source. This enables programmability and also help us to leverage the workforce development and cellular telecommunication network from the application layer to the physical layer. So this is completely based on SDR, software-defined radio, that basically is produced by National Instruments. We also are focused on open source in other categories. For example, for the radio access networking, the CCI, Commonwealth Initiative, has a partnership with the software radio system from Ireland and Spain, where we are creating here in the United States a unique platform to experiment with SRS-RAN. SRS-RAN is a cellular telecommunication stack software that allow you to deploy the UE, the base station in the core network. Also, we are mainly focusing on OpenStack and also the 5G core, OpenStack and 5G core. And of course, AIML. For AIML component, we have been using, Hopkins and also Kafka. Kafka is a bus, allow us to create a visual bus for data streams, real-time data streams, between the Hopkins, platform framework, and the SMO for non-real-time reach for the O-RAN ecosystem. You know that Hopkins has been shut down this last week, the open source. They are discontinued Hopkins. But this is, we don't care, because what we are using for Hopkins is the main building block where you call the marketplace. That I'm going to talk later on. And of course, the overall testbed follow the O-RAN specifications, because Virginia Tech is part of the O-RAN Alliance, ONF, and also the 3GPP. This is the radio network system architecture that we have. Today we have in the ceiling deployed in the Virginia Tech Research Lab in Arlington, 9 rows, in the ceiling. Each row contains 8 USRP per row. And we have also 4 nodes that is Intel NUC with GPU capability, what we will deploy the near real-time RIC a distributed way, and we call this the edge capability of the testbed. And each row is supplied with a PDU, that is a power distribution unit that allows the experiment remote to tune on and tune off each USRP if needed, And also all the USRPs is orchestrated and synchronized by what we call the octoclock, where you have a basic octoclock per row, and then we have 2 master octoclock, that is octoclock G. And all of this is connected to SDN switch, where you have 2 core switch that is connected to the core of the network, 100 gigas, and you have 4 access switch. All of them is based in ONOS, and it's orchestrates everything. Also, we have the server where you are planning to have soon the NVIDIA connected to the O-RAN ecosystem, where NVIDIA will host what you call AI service to provide the overall intelligence for the network infrastructure of the testbed. Just to talk quickly here, as I said before, the radio network software architecture is based on O-RAN. We're using OpenStack as a cloud environment, and we use a light version of the OpenStack and the AE as edge capabilities. As the radio access network, we are mainly focused on SRS. SRS is standalone, and that's along with non-standalone. Just move forward here. This is the radio network software intelligence. As you know, the XAP and the RAP work as the brain of the overall O-RAN ecosystem. Then we have, the idea is that how you can use this platform to create a workforce development in the O-RAN ecosystem and also the cellular telecommunication networking. To do that, we are enabled all the GUI interfaces for the open source platform in such a way that the people, the students, the graduates that come to us, they have my great facilities to accompany what is going on behind in the background of networking when they deploy on XApp, when they deploy an ADApp, and when they deploy a virtual network function. What is the view that they have of the workflow in the overall system? What happens in each building block of the network infrastructure? And just to finalize my presentation, I will invite you guys to join us in the Mobile World Congress in Las Vegas. Virginia Tech Research Center corporations and the Commonwealth Cyber Initiative, we will have a bus dedicated for the Next G Alliance there, that is coordinated by VTR. Also, we will have a demo and in the Albany project for smart warehouse. Also, we're going to go to demonstrate an end-to-end ORAN ecosystem using AI machine learning, Akuma, non-real-time RIC, near real-time RIC, and the radio access networking, the core networking, and the Mobile World Congress in our book. And also you have there a CBRS-based demo where we have created inside the lab a CBSD prototype based in the SDR, where today we are able to connect, for example, to the Google SaaS test environment and register this CBRS, the SDR-based station to be recognized as a CBSD, but we cannot transmit. That's all that I have. If you have any questions.
Okay, thank you. Do we have any questions?